Today, we will be walking you through practical Wi-Fi design matters using live demonstrations. Here we have the Kiviniemi Joel Crane.
But real quick, there's some things that are really essential when you're designing a network. Let's start with concrete. And we start moving it around on the network.
That's a pretty sticky client right there.
Yeah.
Today, we will be walking you through like practical Wi-Fi design matters using live demonstration stuff like that. So we'll be looking at kind of like the title of the webinar was designing robust Wi-Fi, and we'll be mostly actually showing live examples. We also have a slide deck that some of the group participants already have. That's called Ingredients for Designing Better Wi-Fi. If anybody wants this deck, just hit us up either on the chat or just email us directly. We will put our emails here as well, and you just ask for the deck and you shall get it. It's like, I don't know, 30-40 pages of just regular how to design Wi-Fi, how to take care of the generic matters, what to look at when what are the criteria, but also a bit more advanced topics, like a couple of words about designing for location tracking and things of that nature. Yeah, I'm Jussi from Hamina Wireless, and here we have the Kiviniemi Joel Crane on dual camera mode.
Good. You get stereoscopic view of me, but hey everyone, it's nice to be here. Good to see you.
I will maybe stop this video, and you can use mine as a microphone, and there you go.
Sounds
over to Joel.
Sounds good. Yeah, so we won't really spend a whole lot of time in this slide deck. We'll just provide it to you so that you can use it as a resource afterwards, and we'll focus on live demonstration and doing things a little bit more hands-on. But yeah, real quick, just about us, that you know who we are. We've got a tool here called Hamina Network Planner. We're a small company called Hamina Wireless based out of Finland. We make tools for designing Wi-Fi and 4G and 5G private cellular networks, as well as some IoT stuff like Bluetooth, Zigbee, and Enocean. And we also do some swithing. There's some swithing capabilities here.
Who wrote that garbage?
I don't know.
Could be fired.
Yeah, fire that guy. But yeah, we make a tool for planning that, and we're working on a tool to survey networks as well. That'll be coming out pretty soon. But we'll try to keep this as vendor non-specific as possible. We'll try to keep this like something you could use with any other vendor. I mean, the things that we'll show you today, most of it you can do with other tools that are out there. So we'll keep it neutral in that way. But real quick, there's some things that are really essential for when you're designing a network. Of course, the first thing that you need is a floor plan. It really just is not possible to design a wireless network without a floor plan. This could be a JPEG, a PNG, a PDF, maybe something as fancy as a CAD file. I've even taken a picture of the fire escape route when I'm in a pinch. So it doesn't have to be anything really fancy. And then sort of the way that I do these networks when I design a network, I'm typically designing for, first off, what I would call primary coverage. So I'm kind of setting a requirement for myself, like, oh, I want to meet a requirement of maybe -67 dBm or better. Remember that dBm is in negatives, and so -70 is a lower measurement. -50 is a really high signal strength, and so you kind of have to think of it backwards because we're down in the negatives. So that's the first one. Second is secondary coverage. So this requirement says we want to be able to hear 2 or more access points above a certain threshold. I'll show you what that looks like in the tool. I'm also going to try to avoid co-channel interference. That's when we've got 2 access points on the same channel. When they're on the same channel, they have to take turns talking. If you've ever worked with Ethernet hubs, you know that that's not a good thing at all. Fortunately, now that we've got Ethernet switches, we don't have that issue on the Ethernet side as much anymore. But access points are really more like Ethernet hubs than they are switches. We also have to think about capacity, like how many clients do we want to support? And we also have to think about how many switches are we going to need to power our access points? What are our cable runs going to look like? How much PoE are we going to need to accomplish our goals and deploy all the access points that we need to deploy? Now, a little bit later in this, we'll also talk a little bit about Wi-Fi 6E. We'll talk about how to select, special antennas, maybe directional antennas. We'll talk about how to measure the client experience, what private cellular looks like, and maybe we'll also spend a little bit of time in like real-time location services and Bluetooth location services before getting into the recording and wrapping things up. Now, there's a ton more slides here. I'll just give you a quick preview. There's all kinds of different slides here that you can check out if you want, but just let us know if you want these, and we would be happy to send those over.
And yeah, just a side note, the chat is now successfully enabled. I was fat fingering it before, so it wasn't working before, but the chat is now enabled. If you want to ask for it there, we also put in our emails there, so you can ask it there as well. And I see people have also found the Q&A, maybe because chat was lacking. So I'll be on the chat and I'll be on the Q&A while Joel does the heavy lifting. Over to you, Mr. Crane.
I don't know about heavy lifting, but
medium weight lifting.
Medium weight lifting. All right, sounds great. So I think what we should do is let's just start out by just doing a design. I'll just show you kind of what it looks like to do a design from start to finish. And at first, we'll just focus on sort of your regular 2.4 gigahertz and 5 gigahertz wireless network. And we'll do so in an office building, in a multi-story office building, so you can see what all of that's going to look like. So here we go, running Hamina Network Planner here, but in the interest of being vendor neutral, other tools out there, of course, include Ekahau Site Survey. There's also Tamograph. There's VisiWave. There's a few other tools. IBWave. Yeah, there's definitely other tools out there that do this sort of thing. But yeah, we'll start by just creating a new project. And I'm just going to call this one, we'll call it generic office building. And I'll leave the country alone for now, but we'll set the environment to office, mostly rooms, and then hit save. And now we've got a new project that we could start in. Now, one thing I'm going to typically do when I start a project like this is I'll begin by taking some notes about what kind of clients we're going to support. Like maybe we're planning on supporting 200 iPhones. Maybe we're planning on supporting 200 MacBooks. Maybe we have 50 barcode scanners, for example. And so I'll typically kind of take some notes about what kinds of clients I want to support.
And this will come handy later. This is just a note-taking tool, but we will be using these then later in the tool as well when we actually do the high-capacity design. But you can put in pictures, text, any links, anything you want here.
All kinds of stuff. I might put in some notes here about the project requirements. Basically, what I'm getting at is I like to have sort of a single source of truth, a place where everything is documented. And I typically do that within my design tool so that the design project has every single thing in it. That's the one place that everything goes.
Most people use like Microsoft Word or Apple Notes or whatever documents for this. They're great, but it doesn't travel with a project. Now, once Joel actually starts collaborating on this project with his teammates, that's when it's relevant that he's put everything into one place. All he needs to do is click share on Hamina or share this project, and then that'll be all that's needed to be done to transfer all the information to all the team members.
Yep, exactly. Great. So let's move forward then. Let's go grab a floor plan. So I've got a pretty fancy floor plan here. That actually happens to be a PDF. So we'll bring that in really quickly. And what's interesting about a PDF or a CAD file is that in some tools, you can actually have the walls drawn in automatically. And I'll show you what that looks like, but I'll also show you what the manual wall drawing process looks like as well. So here we go.
And why are you drawing walls anyway?
Yeah, that's a really great question. Let's start by just setting the scale, and then we'll drop in an axis point, and I'll show why drawing walls really matters. So having the scale is really, really important for a map because we use that to calculate things like signal strength and signal traveling over distances and how much RF we're going to lose as we go over those distances. Having that in there is very, very important. And so it's a good idea to go get a scale of the building. In this case, what I would probably do is to go in this room with a laser rangefinder and just look down this long hallway and go, oh, that's 56 meters. And then you can mark that scale and type that in. And now you have the scale in your tool all set and ready to go. So then let's just go drop in an AP really quick. Jussi, what do you want to use for an AP today? What do you want to use?
Let's go with Meraki MR something fancy.
All right, so let's go with an MR something. We don't have the something fancy.
Oh, sorry about that.
We'll go with the, how about the 72?
Yeah.
No, that's external. Let's go with like a 70. MR70, there we go. Maybe not. Maybe like
91. Take from the top 91.
9166.
Yeah.
There it is. Yep, MR9166,
and that's a dual 5 configuration. You want to put that on 6 gigahertz as well?
6 gigahertz. Yeah, I don't want to complicate it with dual 5. Okay, so there's our access point is in there. And one thing that every good Wi-Fi design tool out there does is it has specific antenna patterns for each access point model. And so that way your coverage is going to be modeled accurately in the tool. Now that keep in mind, that's what we're doing here. We're creating a model of the network. So now let's go turn on our heat map, and we'll just look at signal strength in the 5 gigahertz band. And you can even see the radiation pattern coming off of that access point. Here's what it looks like in the 2.4 gigahertz band. Here's what it looks like in the 5 gigahertz band. Here's what it looks like in the 6 gigahertz band. But we'll focus on 5 gigahertz for now. But what happens if we start drawing some walls? So I'm going to go into the draw walls tool, and let's start with concrete. So we'll just zoom in on like the stairwell here, and I'm just going to do like a little left click, and then right click to stop. And now you can see the shadow that's made by that concrete wall. And if we continue to add concrete to this area here, you can start to see how much RF that concrete is going to block. Of course, there's other materials too, like maybe we have like a heavy drywall or plasterboard or something like that. We could start drawing that in, and you can see that that's also going to impact the signal strength as well, although it's impacting it to a lesser degree because it's a more RF opaque material. RF has a better time going through.
RF opaque. Now there's a fancy term of the day for you guys.
Yep, RF opaque. Something that RF can get through, radio frequency and signal strength can get through more easily. So yes, thank you for putting that in the chat, Jussi. Okay, so we could go through and draw in all of our walls manually, and I do that all the time. I have no problem doing that. I find it's kind of relaxing and sort of therapeutic, but with a lot of tools, especially Hamina, also Ekahau I know can do this as well, is some tools will draw in the walls for you automatically. So you could go through and say, well, let's go pick this layer and say that this is a heavy drywall. Let's go pick all the doors and say that those are a solid wood wall. And then let's go pick there's some glass and some windows here. Maybe we can find it in a layer here as well. Apparently I can't click on that. There we go. So let's see if there's any glass in here. Yeah, I guess there's no glass in oh, there's window right there. So we'll select window and say that's a window profile. And so this only works if you have either a CAD file or in our case, a PDF with vector graphics in it. You can't do this on a flat image file like a JPEG or a PNG. You do need something that came from a CAD tool for this to work. If it's a JPEG or a PNG, you draw them in manually, no big deal. I do it all the time.
Exactly, and for example, IBWave and Ekahau do this also from the CAD files. I believe Hamina is probably the only one that does this from PDFs as well.
Yeah, but it's
same concept for PDF and CAD and all of that. And if you're working with a CAD file, the benefit is you get the scale automatically. You may have mentioned this already, but if you have a CAD file, they usually incorporate the correct scale, but always double check the scale because it has a humongous meaning to your design. If the scale is off by 20%, you might end up with 80 and not 100 access points, or you might end up like if it's off by 50%, you might end up with 50 APs where just 25 would have been enough.
Yeah, absolutely. So now that we've got all of our walls, I can actually go through and begin to place some access points in here. And I'm just going to go really simple for now. I want to move up. This is the basement. I want to move up and do the design on another floor that's a little bit more interesting. But there we go. We've got some access points in there, and we've basically done a very quick network design on this floor.
You want to show kind of move an AP and show the difference between when it's in the rooms versus when it reaches the hallway and stuff like that, like really slowly, because it's updating over internet. Like Joel's computer obviously is 50 frames per second, but over Zoom it's a bit slower.
Yeah,
there we go.
Yeah, so you can take the access points and kind of slide them around and decide where the best place to put them is going to be. And so, you know, you could see what the coverage might look like if the access point's out in the hallway. In fact, we can move all of the APs out into the hallway.
Of course, that's the best practice, isn't it?
No. Bad Jussi.
Sorry about that.
Yeah. I don't have a stick or something to hit him with, but
this is what is this workplace?
I don't know. no, it's a toxic work environment.
That's
here.
exactly what it is,
We
man.
threaten each other. But for example, you can see, okay, here's what it would look like if we had, let's put everything into the hallways. Here's what it would look like if we had all the access points in the hallways. The problem is that we end up with these areas where we just don't meet our coverage requirement. You can see here these red areas. Anything that's red is negative 75 dBm or lower. Anywhere that's yellow is negative 65 dBm or lower, and we're just not going to get a great experience for the client in there. We'll talk about that in a little bit.
And you see this often, especially in older hotels. That's a case example. Like look at the ceiling of older hotels. Well, almost without exception, the APs are in the hallways. And then it's a hit and miss if you have room coverage or not. But it works great in the hallways.
Works great in the hallways. But where are the clients? At the end of the day, the clients are in the rooms, not in the hallways. And so it's important to put the access points where the clients are. So I'm just doing another floor really quick. I'm just assigning some materials to everything. We'll grab the doors and say that those are solid wood. And then we'll hit import and we'll let it go through and draw those in really quick. But this is just kind of your nice generic office environment with a courtyard in the middle. So this should make for a pretty good example for a floor plan. So let's go grab our access point tool again. And this time, I'm going to focus on putting the access points in the rooms, since again, that's where the clients are. And sometimes you'll even see me focus on the conference rooms first. I'll start by placing APs in the conference rooms because that's where people are doing high bandwidth kind of things that the Wi-Fi just really, really needs to work well for. And then, maybe we'll drop one out here to kind of fill in some gaps. Maybe we do stick one in this little break room right there to kind of help fill that in, and that looks really good. But one problem with this is we end up with a lot of noise around the edges of our design. And I'd really like to get rid of that if I could. And so the way that I like to do that is by setting a scope zone. In fact, setting the scope of the project is something that I like to do with the customer in advance, or the manager or whoever's in charge of this project. Is I'll go set we'll go decide where does Wi-Fi matter and where does Wi-Fi not matter. So I'll just mark that off really quick and notice that now we get this nice mask around the whole thing and we don't get all that noise, that distraction out.
Exactly. Is there an interior courtyard there? You might want to exclude that out as well, right?
Yeah, we can take that out as well. So we'll just grab the scoping tool again and we'll just draw a box here and say that that's now out of scope. And now it's out of scope. We could even do the bathrooms here if we wanted to, although personally I think it's a really important place for Wi-Fi, but we could go take that out of scope as well.
There you go.
We're still doing calculations there. All the calculations are still happening, but we're just masking it here so you don't have to see it. So you see, what are some places that you typically will take out of scope when you're doing a design like this?
I would probably at least maybe I would put a note in one of the elevators. I would actually put a note in the elevator saying like, this is nice to have. I wouldn't necessarily take it out of scope, but I would say this is nice to have.
Not part of the requirement.
Yeah, exactly. I would do the same for the staircase next door. Maybe I put the same kind of icon there. There you go.
Yeah,
there you go.
So we've got red there. Maybe there's a staircase over here.
Exactly. You're marked with the same thing. And the nice thing is you can change the icons of these. And what I wanted to say is in here, like anyone can start the project in Hamina. Well, first of all, like this is a web-based app, right? So you can just go to hamina.com, sign up, and try it out for free. But I would call salesy users can actually do the scoping of the project for free. They can, together with the customer, put the floor plans there, put the scope zones, put the notes, stuff like that. And only after the salesman has scoped it out with the customer with the free version, they would share it with, let's say, engineer Joel, who would then pay for the tool. That's the kind of things like workflow in Wi-Fi projects is super important. And what some of these tools do is they provide some kind of free version capabilities to assist in that workflow.
Yeah, absolutely.
What we do, our methodology is only the Wi-Fi engineers pay, and sales guys use it for free for scoping out things and setting customer requirements, putting in the floor plans, scoping out zones.
Yep. So what I'm doing right now is this is some kind of pre-work stuff that I would usually do ahead of time. Is I'm going through and defining the scope of the project again, except I'm being really, really granular here and I'm getting like all the little details. And so there we go. Now I've made kind of a complex shape there of here's the exact scope of the network, at least on that floor.
Nice.
So going back upstairs to this floor, there's a few more things that I kind of want to get right on this floor while we're in here. So first off, we've designed for primary coverage. So this is coverage from one or more access points. So we're only guaranteeing around -65 or better, -65 dBm or better of coverage everywhere here. But one thing that we don't have is we don't have redundancy. We don't have two access points covering everything. So if we switch to secondary coverage, this is going to show us anywhere that we have coverage from two or more access points above -67 dBm. You can see there's our cutoff.
Right, and then what if I had a little slightly looser requirement? Like let's say I want neg 70 instead of next.
We could go put that in and say, okay, well, we're going to require two or more access points at neg 70 dBm.
To make sure roaming, redundancy, all of that stuff.
So it's actually pretty good.
It's pretty good. Maybe a couple more APs.
Yeah, maybe a couple more. So I'm thinking like, let's nudge an AP into this corner over here. And let's go drop one in maybe to this room right here. That looks pretty good. Maybe we put one more into this room here.
Exactly. Like as long as you have secondary coverage in the main areas, if it's not like 100%, like here in some of the corners, but the devices are not going to roam there anyway and stuff. So it's maybe not that critical. This is where it comes to like, you know, preference question.
Yeah. So like if we look here, like, are there two access points covering this corner of the room? Nope, there's not two.
Or there are, but not with the requirement, switch requirement we have.
But if we look at primary coverage, yeah, we've got an access point right there. Signal strength from the loudest AP in there is perfectly good. So I try to not get hung up on splitting hairs and like, oh no, there's a little spot right there where it's 2 dB worse than it's supposed to. That's fine. And we're just trying to make sure that we've overall kind of got things into shape. Are there any questions or anything? Or
not here, but I do have a question. I know this may not be the right time, but so that we don't forget. What about tertiary coverage? What would you use tertiary? What does it mean, and what would you use it for?
Yeah, so let's go back downstairs where my coverage was a little bit worse down here. So tertiary coverage. So we have primary, it's coverage from one. Tertiary means coverage from secondary rather means coverage from two. Tertiary means coverage from three or more access points.
Why would you ever need coverage from three or more APs?
That is useful for real-time location services. So if you are using Wi-Fi to locate devices, to say we think there's a device, so the device that we're keeping track of is perhaps in this room or on this side of the building.
This would be the Wi-Fi based location tracking systems, the Era Scouts, the Aristaflow X Eka House, you know, that kind of stuff.
So looking at the map here, this area in green, I guess I put my annotation tool. This area in green is the area that we would expect to have good location accuracy, because that's where we're meeting our location requirement, is in that area. So these days, Jussi, I know you did a lot of real-time location services in the back in the day, but so I know you're a total expert in it. I have not done a lot of it.
My expertise on location tracking is from 2002, so
okay,
it might be a little outdated.
Well, there you go, I guess. So. But there's also other technologies that you can use for things like location tracking, like, for example, Bluetooth Low Energy. So each one of these Meraki 9166s also has a Bluetooth radio on it. And that's modeled as well with tools like this. And so we could say, well, we want to have secondary coverage with Bluetooth, or maybe we want to have tertiary coverage with Bluetooth. Now you can see here that my Bluetooth coverage on this floor, I've actually got pretty decent secondary coverage here. It's actually pretty good here. But maybe we want to kind of beef this up a little bit. Well, we could add some Bluetooth beacons to this as well. So we could say, well, let's go grab some Bluetooth Low Energy beacons, and we'll just fill in kind of these missing areas, these areas that we don't quite have the coverage that we're looking for our Bluetooth location services. And now you can see with just a few very inexpensive little battery powered beacons, we've now got basically perfect tertiary coverage in Bluetooth on this floor.
So just to recap that, what you're doing is you're utilizing the BLE radios in the APs, and you're augmenting those with BLE beacons that are not even connected to the switches.
No, they're just battery powered, stuck to the ceiling somewhere.
Exactly. Speaking of switches,
excellent segue. Wow, you see, it's like it's like you set me up for that. So, I don't have a $20 bill. I was going to sneak over a $20 bill. But
no, we totally have this 100% scripted. I was just reading from a prompter.
right,
It was time for my line.
Yeah, that's right. So yeah, we can, in addition to doing Wi-Fi, we can also do the switching side of things as well. So for clarity, I'm actually going to delete I'm going to delete some of my Bluetooth beacons really quick here, just so we can have things nice and clean, and so that we're just showing where the APs are. So of course, something we need to worry about is first off, how many ports we need to feed all of these APs, how much power over Ethernet we need for all of these, and also the cable runs. How long are the cables going to be? Once we get to about around 100 meters, well, we might have some issues with cable lengths. And so we can do that by adding network infrastructure. So I could say, well, let's just start with a little 24 port switch with 350 watts of PoE, just a really small, modest little switch. And let's go find a place to put it. I think this little mechanical closet right here looks great. So we'll drop that in there. And immediately you can see that we need 200, or we're 230 watts short of being able to power all of these APs with this switch.
Instead of a beefier switch, how about the second switch?
Yeah, let's do that. Let's put it, here's a little closet right here we can tuck it into. So we'll put one in right there.
Excellent.
So now we've got one switch feeding this half of the building and one switch feeding this half of the building. They each have some PoE left, although this one, you see, only has 14.5 watts.
Yeah,
left.
you might be sticking something else to that switch too, wouldn't you?
Yeah,
you know,
like a phone
or a security camera.
Cameras. Wasn't there an entrance to the building? Well, there's a stairway here. We want a camera on that. I think we're probably going to have some desk phones in here. So let's drop desk phones. And just like that, we have now gone over budget on our switch again. So it's time to boost it up to a nice 48 port switch with 750 watts. Now we have a nice big switch in there that can handle all of our requirements. But how much cabling is it going to take to do this building? That's something that we need to think about. And one thing I know that we can do, and I would assume some other tools out there could do this too, is you could also look and see, well, it looks like we're looking at about 780 meters worth of cabling in this building so far. Everything is under 100 meters. Nothing's turning red. Everything looks good there. And so we can know exactly how healthy our cabling infrastructure is going to look like in this design. You see, question, comment, anything?
No. Apparently, according to this, you're doing great, and I should give you $20.
Well,
actually,
if I hadn't given my $20 to my kids, then I would have passed the wallet over to you, and you could pass it back. We should do that next time. We should have a $20.
We totally should. That we're
passing around. That's a terrible idea. I don't know what. But all right. So what if we need to factor in things like interference? How is interference going to look in this design? I mean, we've done a design here for good coverage everywhere. We've got good secondary coverage everywhere. We've got our cabling. We've got all of our PoE clients and switches all planned. But how are we doing from an interference perspective? Well, to fully understand that, what the interference in the building is going to look like, I think we need to go 3D. I think we need to start thinking about this in 3 dimensions.
Did you just say 3D, Joel?
I did say 3D.
Oh, wow.
So what I'm going to do is go to our top floor, and let's bring in all those walls really quickly here. So this will just take a second. We'll say that that's a heavy drywall. There's a bunch of concrete pillars.
So this is now floor number
3.
3.
We're on the 3rd floor now. We're going to grab all of the windows. I'm going to say that those are all a window profile. I'm going to import walls. We'll give it just a second to draw those in. That'll take just a moment. And then the next thing that we need to do is we need to stack this building up, and we need to tell the tool how all the floors relate to each other.
Of course, wireless signals, they don't move only in 3D or 2D, do they?
They go up and down.
Yes,
as well. They do go up and down. So we're going to go to the multi-floor tool. I'm going to assign them all to my building. And then to align everything, I'm just going to drag the images until they line up. So that looks good. Those two all align. We'll go grab this one. And I can see based on the stairway. So there's our stairs. You can see the bottom floor in yellow is actually a little bit narrower. So it actually, the building gets a bit wider as it goes up. But we can line up the stairwells, and that's going to work great. So there we go. Now we've got that all defined. And so already we can see the access points that are on the floors below. And we can see that there is some signal strength coming up through the floor. So let's just finish planning out this floor really quickly. So we'll go turn on our access points again. Let's see. I'm going to go with, we had the Meraki 9166, and we'll go with 3 bands. And I won't even do like a perfect job on this floor. We'll just hit the conference rooms really quickly. So we'll put one in that conference room, one in that conference room, one here, one here, one here. Let's see, we'll do one right there. Let me just select that. And you can see that this sort of planning session, like this part actually goes really quickly. The part where you actually place the APs is not the time-consuming part. It's sort of the setup and things like that. That's the parts that tend to take a little bit more time, at least in my experience. So there we go. Top floor is now done. Let's go back down to our middle floor. So now we're in, of our 3 floors, we have 1, 2, 3. We're in our middle floor right now. Let's go take a look at our interference. So if we look at our interference, you can see that, yeah, we have some interference here. All of these yellow areas are areas where we can hear 2 or more access points above a certain signal strength on the same channel. So that means we've got to reuse channels. We've got access points that are sharing channels, which means they're going to have to take turns talking because only one thing can talk on a channel at a time. So we can make some changes to this by going and looking at our channel settings. Here's all the channels that we're using in our design right now, and we're using 40 megahertz wide channels. We're using a bit wider channels, which means we get higher throughput. We can get more data back and forth quickly, but that means we have half the amount of channels to work with. If we go down to a 20 megahertz wide channel, which is what each one of these numbers indicates, then we'll have twice as many channels to work with. Now, each access point won't be able to talk quite as fast to the client device. They won't be able to hit as high of a data rate, but we'll have them all on separate channels so they don't have to take turns talking, and everything's going to work much more efficiently. So we'll go down to 20 megahertz wide channels and hit save. And now Hamina is going to automatically run a channel plan. So I'm actually going to hide a few things here just to kind of get some of the extra stuff out of the way. But now underneath each access point, you can see there's less yellow. So we found a channel plan that's better. And underneath each access point, you can actually see which channels we put them on: the 2.4 gigahertz channel, the 5 gigahertz channel, and the 6 gigahertz channel. And if you make any changes to the design, then this will automatically rerun the channel plan and find a better plan with less interference. Jussi.
Yeah, so isn't that how modern enterprise infrastructure works anyway? It kind of, if the infrastructure changes, then the radio resource management, reruns and kind of optimizes itself. Of course, like I would say 98% of today's enterprise wireless networks are left on automatic channeling, which is kind of what we assume as well. And this won't be identical. Like if you turn on automatic channeling in your infrastructure, it will not be identical to this, but it will be right results-wise, interference-wise, it will be close, right? As long as you're using the same channel width in your design tool as you're using in your infrastructure.
Absolutely, absolutely. So the way that I handle this is, I am never, ever, ever going to go to my infrastructure and say, oh, access point 42, it has to be on channel 11 and channel 104 and channel 18. No, I'm never going to do that. I'm just using the tool to make a design that has minimal interference, and then I'm going to hand the design over to the infrastructure and let the infrastructure make the decisions about where everything
exactly lands. As long as you constrain the radio resource management so that it has the same channel widths, it roughly uses the same transmit power. Maybe you design in the design tool for the lower limit of the transmit power, and then you give the automatic transmit power control. You give it a little bit of leash, so you design with let's say 10 dBm for 5 gigahertz here, but then you leave some leeway for the infrastructure system to give it like from 10 to 13 or something like that, so it can recover a little bit and cope with the changes and the inaccuracies in the design and all of that.
Yeah, and by the way, you can set the transmit power manually. We could say, let's have it be 20 dBm of transmit power, and bam, now it's blasting huge interference everywhere. But what we like to do at Hamina, and I think a lot of other wireless network engineers like to do the same, is like to design with a lower transmit power, and that gives you some room to go up. So if your model is wrong, if the predictive model that you made ends up being a little bit off or something like that, you can go up on your transmit power to accommodate.
And there's always unexpected changes in the environment. Somebody closes door, somebody moves some of the furniture, even walls are moved. So you want to leave a little bit of
all the
leeway.
time. all the time. Somebody's like, oh, let's install offices in here. And so they start slapping around walls in here. And then you, as the network engineer, you come back 6 months later and they said, the Wi-Fi doesn't work anymore. Well, you come back and you realize that, well, they just added a bunch of walls everywhere. And so now the original design no longer works, is no longer functional, but you've got some room to go up. Or even better, your radio resource management, if you're using Cisco, or your ARM, if you're using Aruba, has already taken care of it, and there's nothing to fix. And so
exactly, every vendor does it these days.
Yeah, just about everybody does that. So yeah. Oh, a mysterious J says hi, UC and Joel. Hey, mysterious J, whoever you are. I have no idea who it is. So
identify yourself,
yeah,
drinker.
right now. Another factor to take into account for multi-floor environments are what about if there's like a hole in the floor? Well, here, this is actually a void. This is like an atrium that goes down to the middle floor. You can usually define that as well. In this case, we're going to do what's called a floor hole. So we'll just draw a big hole in the floor, and there we go. Now, if we go downstairs to our second floor, and let's look at our coverage in 5 gigahertz again. And am I zoomed in really close? Oh, something went weird. Let's try again. 1 second while we switch maps. You seen that before?
No.
Something went weird. Anyway, you can when you've got those kinds of environments, you can draw holes in the floor and things like that to make sure that. Oh, I don't know.
You're good.
Okay, cool. I wasn't sure what you saw. Let's go look again and see if it's good to go now. There we go. So we could say, let's go look at our access points that are on adjacent floors. Like here's an AP that's on the floor above, and you can actually see how the radio frequency activity is, or how the RF is going to come through from that floor and get all the way down to the floor that you're currently on.
Yeah, and it blasts all the way to the other side because of the floor hole, like the previous AP and stuff like that.
Yeah, yeah, absolutely. Something to watch out for. Let's see. VPAN says channel width of 40 megahertz is best practice. What if there is interference on 40 and not on 20? What width should be selected? That's a really good question, VPAN. Here's how I do channel widths. I design for 40s until I can't. I will do
on 5 gigahertz.
On 5 gigahertz. Yep. In the 5 gigahertz band, I start at 40 megahertz wide. And at the point where I have so much channel reuse that now it's starting to cause co-channel interference, that's when I'm going to start backing down to a 20 megahertz wide channel. In the 6 gigahertz band, 80 is the new 40. I'm going to start with 80s, maybe back down to 40s, but then again, we haven't seen deployments yet.
And this depends on the region as well. Some regions do not have 6 gigahertz available today at all. Some of them have only 500 megahertz of space, in which case it might make sense actually to even start with 40, stuff like that. So it's absolutely a preference thing and a regulatory domain thing very much as well. Really good question, VPAN.
Yep.
Keep those questions coming.
Yep. We really enjoy those. Those make for a better webinar. Yeah. What else?
There's another question. For a typical enterprise environment, can we design AP using 5 milliwatts of power instead of 10 milliwatts, considering offset?
That's a good question. So when you say offset, can you describe it a little bit more?
Shreyas, can you describe what you mean? What you mean by offset here? Is it like safety margin, or and you want to change to milliwatts? So we can talk.
So yeah, right now I've just switched over to 10 milliwatts of power. And so typically when I'm going to do an environment like that, like let's say that we have a client device that typically hears about 4 dB worse than my other client devices. So, maybe most of my clients are really happy at negative 65 dBm, but I have a client device that hears 4 dB lower, and I really want to design for that client and get that client to hear negative 65 dBm of all the time. I'm just going to adjust my requirement. I'm just going to do a little offset right here. And I'm going to say, well, instead of designing for negative 65 dBm, we're going to give ourselves 4 dB of margin. We're going to design for 61
and
dBm.
65 already is quite
really high.
Yeah, it's already pretty high. So I think it accounts for some margin. And what we're showing here, that's a really good point, Shreya. So and without going into too much detail, but what we're showing here is we're assuming a 0 dBi fully omni client device, which would be representative of your typical, let's say, an iPhone. So laptops are expected to work a little better. Those absolutely terrible legacy, medical IV pump integrated Wi-Fi dongles or Wi-Fi chips might work a little worse. So that's when you might want to use in safety margin. But typically, if you're designing for iPhones or other decently working, Android phones, things like most Android phones, the current view is all right.
Yeah, absolutely. And sort of the industry standard -67 dBm that we designed for and -65 dBm that we designed for, those are kind of the two prominent numbers. Those two values, at least in my experience, your mileage will vary. You will have slightly different experience than me. That's okay. But in my experience, -65, -67 is already a very, very good signal strength that already has margin built into it. The reality is that most client devices are happy at -70, -72, -73, even -75 dBm. I've had a Zoom call and it's worked totally fine. So when we're designing for -67 dBm, that is typically already has 3 or 4 dB of margin built into it for those least capable or less capable client devices. So, but yeah, if you have a client that you've done testing and you're confident that it needs a few more dB than the others, just adjust your value. We're going to say -64. That's what we're designing to, and that's our offset.
Excellent. And there was a question on DFS, and without going into too much DFS, that's very much your mileage may vary and depends on the environment, depends on how chaotic it is radar signal wise, and let alone like with older equipment you may get false DFS alerts, stuff like that. The point being, you can disable the DFS channels if you want, and they will be ignored by the channelizer, so it won't even suggest DFS channels. But what we can do at some point, or maybe this is a suggestion to the group, somebody else can do this than us and maybe some of our friends, but happy to host a DFS specific webinar as well. It's such a wormhole if you start drilling into DFS. Yeah. But maybe that's an idea for another Wi-Fi nomads topic right there.
Absolutely. So yeah, let's see. Anything that we didn't talk about client roaming at all. Should we talk about roaming?
Let's talk about client experience and roaming. Yeah.
Okay, so I just brought back up our heat map, and I'm going to turn off the access points that are on adjacent floors. So we're just looking at the APs that are on our current floor right now. So then what we can do from there is we can go look at what the client experience is going to look like by going to the client view, and then we can select from a list of clients that we have gone and gotten the roaming behaviors and band preferences and general specifications of. The key here is that we've gotten the roaming behaviors. We've actually talked to the vendors and asked them, like, how does an iPhone decide to roam? When does it decide to roam? How does it decide to roam, who to roam to? And so then we can take that client and we can move it around in the environment, and we will make predictions for when we think the client is going to roam and who they're going to roam to, and also show you things like what's that client's current signal strength. So let's just say that we've got a design, but for whatever reason, management has said we need half as many APs in here. You can't have this many APs. We need half as many APs as you had before. So we'll just go through and chop out half of our access points.
And maybe the management says, but you can always chop up the transmit power to maximum.
Yeah, we can always go up with transmit power. So let's do that. So we'll just grab all of our access points that are on this floor really quick. So we'll say access points, and we'll go like 20 milliwatts or something like that, or maybe
and on 2.4 as well.
Yeah, 30 milliwatts on 2.4. So we've gone crazy with our transmit power.
And it's green, so it works.
Well, and the funny thing is, though, is even though we've gone to a crazy transmit power in the 5 gigahertz band, it's mostly green.
Yeah,
it's
but
not all the way green, although 2.4 is green everywhere, which means it's going to be great, right?
No, how about the client experience, though?
Yeah, let's take a look at the client experience. So now if we go grab our client device and we start moving it around on the network.
That's a pretty sticky client right there.
Yeah.
Oh, so and see the area. That's the amount of stickiness the client has.
So the client is going to have to leave this blue area before it will roam to another AP. Look how far it has to get from that access point before it'll roam. So
and this is an iPhone, so this is actually pretty sensitive at roaming. A laptop would still be like it would be.
Let's go look at a laptop.
Yeah, it'll be a little further out that it roams.
A
actually,
laptop.
there you go.
Yeah, a laptop. We might end up. Let's see. Let's go back up to this AP. So we got to go all the way back up there. We might be all the way down here.
Yeah, look at what happens with data rate and all of that.
Look at that.
Before it roams.
We're down. We were all the way down at -60, or we're all the way down at like 65
Oh,
megabits per second.
that's a sticky one right there.
Yeah, this one's bad.
Like if you happen to roam to that AP, you can be almost anywhere in the building and still not roam.
You will never ever get away from that AP. We're on the opposite side of the building. We're all the way down to about 100 megabits per second. We're still stuck to that AP over there. So you can use this to predict. Oh, go ahead, Jussi.
So yeah, sorry, just a catastrophic scenario. Let's say that AP where we were like that was like super sticky. What if that what is yeah, and now we're actually on another radio, so it's not quite as sticky. You see how we roamed to 5 gigahertz, and the situation got a little better. Now we're back on 2.4 again. So if you happen to be on this radio on 2.4, let's say this AP is close to the entrance of the building. Everybody sticks to that AP almost forever. And how does that work with capacity? Well, not great.
Not great. That AP gets overloaded. That channel gets overloaded. Everybody's data rates are awful. Everybody's throughput is awful. Everybody's mad. Even though you have other APs in the building, they're getting underused. So let's go. Let's go fix our. Well, let's take it a step further. What if they say, well, they have to be in the hallways? We have to have the access points in the hallways. Mm-hmm. Okay.
So and you can't go that crazy on the signal strength.
Yeah. So you're saying we should back down the transfer?
I don't know if you want to. Depends on the example you want to illustrate.
Well, let's see what happens really quick. So now that we have all the APs in the hallways, now we're going to have even worse sticky client problems.
Certainly didn't.
Because look at this, we got all the way down to less than 200 megabits per second there, stuck to that AP. And the other thing that'll happen is, like, let's say that you've got a client that's going to walk around the corner. The signal strength is going to fall off a cliff when you go around the corner. So the client device is not going to have hardly any time to roam. It's going to have to make a super fast roaming decision, which means you're going to have several seconds of dropped packets, which means the voice call or the video call that they're doing isn't going to work. And so that's what I love about having something like this, is the ability to measure what's actually going to happen in our environment. Let me switch back over to DVM really quick.
Absolutely. And can you put them identical for one, like once more? Yeah, there you go. Like
10 and 10.
10 and 10.
Sure.
So as we know, keep it there. As we know, the client makes the roaming decision, right? And then people ask, like, why don't we default to identical transmit powers for 2, 4, and 5? Here's the reason. So the client, even though the iPhone, for example, or MacBook, even MacBook, which we're using here, it does prefer 5 gigahertz pretty heavily, but 2.4 just radiates so much further. It's just so much stronger in any position than 5 gigahertz if identical transmit powers are used. You want to use a significantly higher transmit power on the 5 gigahertz radio in order to lure the clients into 5 gigahertz, where you usually have a lot more space. So using this like client view, you can actually see what would happen also for that, like in terms of 2.4 versus 5 and all of that. And we do have things like, high capacity SD planner and things like that. Maybe we'll leave like high capacity planning and advanced, some of the advanced topics to another webinar if there's interest or stuff like that. But yeah. Now that there's 10 minutes, we didn't talk about reporting or capacity stuff like that, but I think that's fine. Should the Nomads admins allow, and if the people desire, we'd be happy to talk about like more different advanced concepts later. But now might be a good time for questions as well as sign off, Vishnu, if you have anything to add here. Are you okay with that?
Oh yeah, that's perfect.
We're just 8 minutes from the top of the hour.
Yeah, I think we can ask the community for any questions now, Jussi. I think so far, great.
Excellent. Hey, you want to show like while you're showing 3D, you want to show speaking of 3D, you want to show a warehouse example real quickly and kind of like directional antennas. That would be like a fundamental thing that we probably should cover.
We can do that. Let's go take a look at a warehouse really quickly. So this is an example of a warehouse. I've got a wall taken out of here just to make it a little bit easier to see. But here we've used, most tools out there support drawing 3D objects like this. Most don't support showing it in 3D like we do. I will say it's something that's specific to us as far as I know. But you can see that we've drawn in like the shelves, for example, and here's an HVAC duct up here. And it's all presented in 3D. And then you can do things like, okay, well, let's play with some antennas for a minute. Like what happens if we do a directional antenna on this floor plan? So we could say, let's put a Juniper AP43 and let's give it some down tilt so it's pointing down at the floor. So you can see here we're using a patch panel antenna pointing it to the ground. We could say, well, let's play with some different ideas. Like maybe let's put it on the ceiling and point it straight down, but it's still 9 meters high. So that's the area it's going to cover. What if we drop it down closer to the floor? Maybe it's only 4 meters from the floor. Now you can see the coverage area tightens up quite a bit. So using a predictive modeling tool like this is a great way to experiment with different access point options, different antenna options, different mounting options, different down tilt, how much it's pointing down. And it can really enable you to come up with some very unique and interesting designs that solve specific problems in specialty places like this.
What about if I have a warehouse where I have autonomous robots at 5 meters, roaming at 5 or 8 meters height or stuff like that?
Absolutely.
Does the 3D view somehow help me illustrate that?
Yeah, absolutely. So if we've got if we're looking at our coverage right now, by default, we're looking at coverage that's only 1 meter off the ground.
So that's where your normal walking or sitting person would be, or like computers.
So what's it look like up towards the ceiling? Maybe we've got people on forklifts, or like you said, autonomous robots.
Yeah.
Now you can see what the coverage is going to look like.
So you can just set the client height at the robot level, or pull it back down.
Yep,
stuff
exactly.
like that.
So we could say, here's what it looks like 1 meter off the ground. Here's what it looks like 9 meters off the ground. So we have great coverage up in the ceiling here.
As is usually the case in warehouses and retail stores. But then between the shelves, it's a different story. Well, what about the crazy place like stadium?
Yeah, absolutely. Do I have a stadium here?
Ooh. Hockey arena or something like that?
I have my hockey arena on this one. So let's go take a look and see what I've got for my hockey arena.
So on these kind of places, you might want to, not model yet. That's fine. That's totally fine. Oh, you do have a football stadium.
I do have it's an American football stadium.
Oh, American football. So it must be great.
Yeah, maybe. So yeah, but yeah, a lot of these tools out there will allow you to get very, very granular on what you can model and where.
And this is like, for example, on a stadium, you want to plan for some like APs on overhangs or shooting from the back with directional antennas. Then maybe you want to put like typically stadiums, like if you can decide, one good option also is under the seats, where like crowd sitting on top of the seats actually attenuates the signal nicely, enabling frequency reuse. But yeah, the other alternative is like from the top, you might have handrail antennas, all of that kind of stuff as well.
There's an example of an antenna pointing down into the crowd. So it's actually located 20 meters above the pitch here, pointed down at a 45-degree angle into the crowd. And this is one of those fancy APs with an integrated directional antenna. There's the antenna pattern that's coming off of it.
It's very tightly loaded.
Very tightly loaded, which is great because then now if you're supporting a huge number of clients all in one area, you can split up all the clients onto separate radios, onto separate channels. You can keep your performance nice and high.
Nice.
Yeah, I think we've taken too much time to talk about that. Questions, comments, anything before we are done today?
I think we are good on the questions.